Hello, hi everyone. Welcome to the Student in the Brand. This is your Shiva sir. Today topic is electric current. Today we are going to discuss about electric current. CBSE Grade 10 Physics. CBSE Grade 10 Physics. So I equal to Q by T. SI unit of current is ampere. So electric current. Electric current. CBSE Grade 10 Physics. CBSE Grade 10 Physics. So electric current is nothing but I equal to Q by T. So I equal to Q by T. Rate of flow of charge is called electric current. Rate of flow of charge. I equal to Q by T. I equal to Q by T. So SI unit of current is ampere. SI unit of charge is coulomb. SI unit of current is ampere. SI unit of charge is coulomb. I equal to Q by T I am talking. So I equal to Q by T. Okay. So now here I am considering SI unit of electric current is ampere. SI unit of electric current is ampere. SI unit of charge is coulomb. SI unit of charge is coulomb. SI unit of time is second. SI unit of time is second. I equal to Q by T. The rate of flow of charge. The rate of flow of charge is called electric current. The rate of flow of charge is called electric current. I equal to Q by T. So SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. So 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. That is called electric current. I equal to Q by T. Right? Now, so here inside of the conductor, charges will move. So charges will not move alone. So there are many charges will move inside of the conductor. Positive charges as well as negative charges will move. So positive charges at the same time negative charges. So both will move. Positive charges and negative charges. Both will move. So that's why quantization of charge Q equal to plus or minus Ne. Quantization of charge Q equal to plus or minus Ne. Okay. So N equal to I am considering. So N equal to we can take N equal to, so number of charges. N is the number of charges. So on one electron, if you are taking on one electron 1.6 into 10 power minus 19 coulomb. So on one electron 1.6 into 10 power minus 19 coulomb. See, in 1 coulomb, how many electrons are present? In 1 coulomb, how many electrons are present? We will see now. In 1 coulomb, how many electrons are present? On 1 electron, 1.6 into 10 power minus 19 coulomb. In 1 coulomb, so you can take 1 by 1.6 into 10 power minus 19. Then 1 by 1.6 into 10 by 10 into 10 power 19. Okay. So then we will get it. So that is 1 coulomb. 1 coulomb equal to 1 by, so 10 by 16 into 10 power 19. If you solve this one, you will get 0.625 into 10 power 19. Then 1 coulomb, if you are taking 6.25 into 10 power 18 electrons. Okay. So this is about okay. So I equal to Q by T. S unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. So inside of the conductor charges will move. Inside of the conductor charges will move. Charges will not move one or two. There are many charges. So number we are taking. So that is n. Q equal to plus or minus ne. So plus or minus ne we are considering. So okay, number of positive charges or negative charges are there. On 1 electron, 1.6 into 10 power minus 19 coulomb. In 1 coulomb, 1 by 1.6 into 10 power minus 19. So if you are solving, okay, so 1 by 1.6 into 10 by 10 into 10 power 19. So then 1 coulomb equal to 10 by 16, you'll get it 10 into 10 power 19. 0.625 into 10 power 19. 1 coulomb equal to 6.25 into 10 power 18 electron. Okay, so this is about electric current, quantization of charge, electric current and quantization of charge. On 1 electron, 1.6 into 10 power minus 19 coulomb. So in 1 coulomb, 6.25 into 10 power 18 electrons are present. So this is about electric current. Electric current. Okay. So once look at the board, you can check once. Next we are going to the one more electrical appliances. Electrical appliances. Electrical appliances. Now we will discuss first one, cell, battery, so switch, So cell, battery, so switch, open switch, closed switch, so resistor, rheostat. So this one is wire joining, wire crossing, wire crossing, wire crossing, and here ammeter, ammeter, voltmeter, 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 bulb. So here these are the cell. So cell, battery, open switch, closed switch, resistor, rheostat, wire joining, wire crossing, ammeter, voltmeter, bulb. So these are the electrical appliances. These are the electrical appliances. Electrical appliances. So resistor is a device. Resistor is a device which is used to oppose electric current. Resistor is a device which is used to oppose electric current in the circuit. Resistor is a device which is used to oppose electric current in the circuit. So resistance is a phenomena of opposing the electric current. Resistor is a device which is used to oppose electric current in the circuit. Resistance is a phenomena of opposing the electric current. Resistance is a phenomena of opposing the electric current. Next one, rheostat. Rheostat is Rheostat is nothing but so the device which is used to uh, regulate the current without changing the voltage source. The device which is used to regulate the current without changing the voltage source is called rheostat. Ammeter is a device which is used to measure the electric current. Ammeter is a device which is used to measure the electric current. So voltmeter is a device. Voltmeter is a device which is used to measure the potential difference. Ammeter is connected in series combination. Voltmeter is connected in parallel combination. Ammeter is connected in series combination. Voltmeter is connected in parallel combination. So ammeter will be connected to measure the current. What is use of ammeter? To measure the current. SI unit of electric current is ampere. SI unit of potential difference is volt. SI unit of potential difference is volt. Okay. So this is about okay. So this is about electric current. Now we are going to discuss one more. Electric circuit. Electric circuit is nothing but a continuous and closed path of an electric current. A continuous and closed path of an electric current is known as an electric circuit. A continuous and closed path of an electric current is known as an electric circuit. Okay. So here a continuous and closed path of an electric current. A continuous and closed path of an electric current is known as a continuous and closed path of an electric current is known as an electric circuit. An electric circuit. So first one is conventional current. Conventional current. Conventional current. Second one is electric current. Electric current. Conventional current is nothing but the flow of positive charges. The flow of positive charges is considered as the flow of positive charges is known as conventional current. Electric current is nothing but the flow of electrons. The flow of positive charges is considered as the conventional current. The flow of positive charges so is known as conventional current. Flow of positive charges. So positive charges will move from high potential to low potential. Positive charges will move from high potential to low potential. Positive charges will move from high potential to low potential. So conventional current is nothing but the flow of positive charges. So flow of positive charges. Positive charges will start from high potential to low move high. It will start from high potential to and reach to the low potential. So it moves from high potential to low potential. It moves from high potential to low potential, positive charges. Whereas negative charges will move from low potential to high potential. Negative charges, positive charges will move from high potential to low potential. Negative charges will move from low potential to high potential. Low potential to high potential. This is about conventional current. And coming to the electric current. So electric current is nothing but negative charges will move from low potential to high potential. So positive charges will move from high potential to low potential. So that is a conventional current. This is electric current. Conventional current and electric current. Conventional current and electric current. Okay. So next one here. This is about electric current and conventional current and electric current. Okay. So as I said, positive charges will move from high potential to low potential. Positive charges will move from high potential to low potential. Electrons will move from low potential to high potential. So this is about electric circuit. So potential difference is nothing but work done to bring unit positive charge. Potential difference. Potential difference is nothing but, so I am taking here positive A and a B. So positive charge, we are doing some work. Potential difference is nothing but we are doing some work to bring unit positive charge. Potential difference is nothing but work done to bring unit positive charge from one point to another point within the conductor. Work done to bring unit positive charge from one point to another point within the conductor is called potential difference between. So work done to bring unit positive charge from one point to another point within the conductor is called potential difference. V equal to W by Q. So potential difference is equal to work done to bring unit positive charge from one point to another point. Potential difference is nothing but work done to bring unit positive charge from one point to another point within the conductor is called. Okay, so within the conductor is called potential difference. Electrical potential. So 1 volt. What is SI unit of potential difference? Volt. SI unit of work is joule. 1 volt equal to 1 joule by 1 coulomb. 1 volt equal to 1 joule. 1 volt equal to 1 joule by 1 coulomb. So 1 volt equal to 1 joule by 1 coulomb. So what is the potential difference? Work done to bring unit positive charge from one point to another point within the conductor. Work done to bring unit positive charge from one point to another point within the conductor is called potential difference. Coming to the electrical potential, electrical potential, electrical potential. Electrical potential is nothing but work done to bring unit positive charge. So I am taking this the positive charge. So we are doing work to bring unit positive charge from one infinity to the required field. Infinity to the required field. Infinity to the required field. Work electrical potential is nothing but work done to bring unit positive charge from infinity to the required field. From infinity to the required field is called electrical potential. Infinity to the required field is called electrical potential. Work done to bring unit positive charge from infinity to the required field is called work done to bring unit positive charge from infinity to the required field is called electrical potential. Potential difference is nothing but work done to bring unit positive charge from one point to another point. From one point to another point. That is called potential difference. What is the potential difference? Work done to bring unit positive charge from one point to another point within the conductor is called potential difference. Work done to bring unit positive charge from infinity to the required field is called electrical potential. Potential difference and electrical potential. Potential difference and electrical potential. Right? So formula is same only. Formula is same. So V equal to 1 volt equal to 1 joule by 1 coulomb. 1 coulomb V equal to W by Q. V equal to W by Q. Formula is same only. Formula is same only. Next one we will discuss about Ohm's law. So we are going to talk about Ohm's law. Ohm's law is nothing but work done to bring unit positive charge. Work done to bring unit positive charge. Potential difference. Work done to bring unit positive charge from one point to another point, that is called potential difference. Ohm's law is nothing but the potential difference across the ends of the given metallic conductor. The potential difference. Okay, so let's get into the topic. The potential difference across the ends of the given metallic conductor. The potential difference across the ends of given metallic conductor is directly proportional to current flowing through it. Is directly proportional to current flowing through it at a constant temperature. V is directly proportional to I, V equal to IR. So the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. So V is directly proportional to I, V equal to IR. Okay. So next one, materials required. What are the materials required? So materials required. Materials required. Materials required. Okay. So first one you have to take 4 cells. 4 cells you have to consider. 4 cells. 4 cells. 4 cells of 1.5 volts each. And second one, nichrome wire is an alloy of nickel chromium. Nichrome wire. So 0.5 meter length. And third one, 4 cells 1.5 volts each. 4 cells 1.51. So how many cells are there? 4 cells. 1, 2, 3, 4. 4 cells of 1.5 volts each. Okay. And nichrome wire is 0.5 meter length. This is a nichrome wire. So X and Y. Right. And ammeter. And fourth one, voltmeter. Fifth one, nichrome wire voltmeter switch. And sixth one, connecting wires. Once again, you can observe here. So Ohm's law is nothing but the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. The potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it at a constant temperature. V is directly proportional to I, V equal to IR. Materials required 1.5 volts each. So 4 cells. Nichrome wire is an alloy of nickel, chromium, manganese and iron metals. Ammeter, voltmeter, switch, connecting wires. Okay. Next one, procedure we have to take. So procedure, connect one cell and note down the reading of ammeter and voltmeter. So procedure, first you have to connect one cell. Connect one cell and note down the reading of ammeter and voltmeter. Next, connect two cells. And repeat the process for 3 and 4. Once again, connect one cell and note down the reading of ammeter and voltmeter. Connect one cell and note down the reading of ammeter and voltmeter. Connect two cells and note down the reading of ammeter and voltmeter. Repeat the process for 3 and 4. Repeat the process for 3 and 4. Okay, repeat the process for 3 and 4. Then mention the values in the tabular form given below. So I am taking here this the tabular form. Serial number of cells. So ammeter, voltmeter, V by I, that is R. 1, 2, 3, 4. So I am taking 4 cells. Okay. So 1, 2, 3, 4. So ammeter reading, voltmeter reading, V by I value. V by I value. Okay. Now you can see. So the potential difference across the ends of the given metallic conductor, the potential difference across the ends of the given metallic conductor, V is directly proportional to I, V equal to IR. Materials required 4 cells you have to take 1.5 volts each. Nichrome wire is an alloy of nickel, chromium, manganese and iron metals, and ammeter, voltmeter, switch and connecting wires. So procedure. First connect one cell and note down the reading of ammeter and voltmeter, and connect two cells and note down the reading of ammeter and voltmeter. Repeat the process for 3 and 4. Repeat the process for 3 and 4. Repeat the process for 3 and 4. Okay. So then you can mention all the values in the tabular form. So if you draw the graph, VI graph, the graph is linear starting from origin. V on y-axis, I on x-axis, V on y-axis, I on x-axis. If you draw, okay. The graph is straight line. That is for ohmic conductor. This is for ohmic conductor and this is for non-ohmic conductors. Ohmic conductors and non-ohmic conductors. Ohmic conductors. Ohmic conductors. Non-ohmic conductors. Okay, check once. So this is about Ohm's law. This is about Ohm's law. So the potential difference across the ends of the given metallic conductor is directly proportional to I. V equal to IR. Materials required 4 cells, 1.5 volts each, 1.5 volts each, 1.5 volts like that 5. So 4 cells. So nichrome wire is an alloy of nickel, chrome, manganese and iron metals. So ammeter, voltmeter, switch, connecting wires. Procedure: connect one cell and note down the reading of ammeter and voltmeter. Connect to two cells and note down the reading of ammeter and voltmeter. Repeat the process for 3 and 4. Mention in the tabular form given below. Okay. So draw the graph for VI. So here ohmic conductors, the substances which obey Ohm's law, those are called ohmic conductor. The conductor which does not obey Ohm's law, those are called non-ohmic conductors. Non-ohmic conductors. Yes or no? So this is about ohmic conductors and non-ohmic conductors and Ohm's law, potential difference. So can anyone say what is the potential difference? Few questions until so resistance we will ask. Resistance will ask. So I'll ask questions. Try to answer it. So then, so we'll ask questions. Name the SI unit of electric charge. What is the SI unit of electric charge? SI unit of electric charge. SI unit of electric charge. And how many electrons are constituted in 1 coulomb of charge? How many electrons are constituted in 1 coulomb of charge? So normally on one electron 1.6 into on 1 electron 1.6 into 10 power minus 19 coulomb. In 1 coulomb 6.25 into 10 power 18 electrons are present. Okay. So next one. Define electric current. What is electric current? Rate of flow of charge. Rate of flow of charge, right? Rate of flow of charge. And next one, state the relationship between 1 ampere and 1 coulomb. State the relationship between 1 ampere and 1 coulomb. So what is the relationship between 1 ampere and 1 coulomb? 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. Okay, next. What is ammeter? What is an ammeter? How it is connected in a circuit? Ammeter is a device. Ammeter is a device which is used to measure the electric current. Ammeter is a device. Ammeter is a device which is used to measure the electric current. Okay. Ammeter is connected in series combination to the circuit. Right? Okay. Next question. So what is the potential difference? Anyone, what is the potential difference? Potential difference. Potential difference is nothing but work done to bring unit positive charge from one point to another point within the conductor. That is called potential difference. SI unit of potential difference is SI unit of potential difference. Volt. What is meant by resistance of the conductor? Resistance is nothing but what is meant by resistance of the conductor? Resistance is nothing but the phenomena of opposing the electric current. SI unit of resistance is resistance. Resistance is the phenomena of opposing the electric current. Resistor is a device which is used to oppose the electric current. SI unit of resistance is ohm. SI unit of resistance is ohm. Okay. State the relationship between 1 volt and 1 joule. 1 volt and 1 joule. State the relationship between 1 volt and 1 joule. 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point. Okay. So few questions are there related to problems. So those problems will do it. So next one. So hi everyone. So now we will discuss about resistance and resistivity. Now we will discuss about resistance and resistivity. Okay. So resistance is nothing but okay. So resistance and resistivity. Now we will discuss about resistance and resistivity. Resistance, if you are taking, okay, resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the conductor. Resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the conductor. So R equal to rho into L by A. R equal to rho into L by A. So R equal to rho into L by A. Rho equal to RA by L. Rho equal to RA by L. So check once here. You can check there. So resistance is directly proportional to length of the conductor. Resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the cross section. R equal to rho into L by A. R equal to rho into L by A. Rho is the resistivity. R is the resistance. Rho is the resistivity. R is the resistance. Okay. So now R is the resistance. Rho is the resistivity. Okay. So now we will discuss about resistance and resistivity differences. The difference between resistance and resistivity. Difference between resistance and resistivity. So hi everyone, now you can see resistance R equal to rho into L by A, resistance R equal to rho into L by A, rho equal to RA by L. SI unit of resistance is ohm, SI unit of resistivity is ohm meter, ohm meter, ohm meter. So SI unit of resistance, the symbol is ohm. Okay, resistivity is ohm meter. Resistance depends on length and area. Resistance depends on length and area. Resistivity does not depend on length and area. Resistance depends on temperature. Resistance resistance depends on temperature. Resistance depends on material. Resistivity depends on temperature. Resistivity depends on material of the conductor. Right? So this is about difference between resistance and resistivity. Difference between resistance and resistivity. Okay. Check once everyone. Once again. So resistance R equal to rho into L by A. Resistivity equal to RA by L. SI unit of resistance is ohm. SI unit of resistivity is ohm meter. Resistance is symbol. So resistivity symbol. Resistance is depends on length and area. Resistivity does not depend on length and area. Resistance depends on temperature. Resistance depends on material. So resistivity depends on temperature and also resistivity depends on material of the conductor. Right? Next, any doubts? So check once. So I hope it is very clear. Next one we will discuss one more. That is resistors are connected in series. Resistors are connected in parallel. Next one, resistors are connected in series. Resistors are connected in parallel. Now we will discuss resistors are connected in series combination. Resistors are connected in series combination. Okay. Resistors are connected in series combination. Chalo then. So resistors are connected in series combination. Resistors are connected in series combination. So all resistors are connected in such a way that all resistors are connected in such a way that, okay, so the current in series combination, will be same. Okay, now you can see. So I'm taking 1, 2, 3. So ammeter, the physical quantity which is same in series combination is current. The physical quantity which is same in series combination is current. The physical quantity which is same in series combination is current. All resistors are connected in series combination. The potential difference is different in series combination. Do you know that? Potential difference is different across R1. So potential difference is different across R2. Potential difference is different across R3. That's why I am taking Vs equal to 1 plus V2 plus V3. But current is same. Is equal to I1 equal to I2 equal to I3. Current is same. That's why I am taking here Is equal to I1 equal to I2 equal to I3 equal to I. Current is same. Current is same in series combination. But potential difference is different. Vs equal to V1 plus V2 plus V3. So that is, so Vs equal to V1 plus V2 plus V3. So IRS Vs is nothing but IRS IR1 plus IR2 plus IR3. Anyway is common. I is common in series combination. So IRS equal to IR1 plus IR2 plus IR3 equal to IR1 plus IR2 plus IR3. I is common. That's why I'm taking I common. I am taking common. So you can take I common and cancel it. R1 plus R2 plus R3. So I'm taking I common and cancel the I value. So if you're you'll get I get cancel. Rs equal to R1 plus R2 plus R3. So this is about resistors are connected in. Series combination. Resistors are connected in series combination. If a number of resistors are connected in series combination, Rs equal to NR. If n number of resistors are connected in series combination, Rs equal to NR. If n number of resistors are connected in series combination. Once again, see Rs equal to NR. So here entire the resistors connected in series combination. Resistors are connected in series combination. R1, R2, R3 are connected in series. So current is same, Is equal to I1 equal to I2 equal to I3 equal to I. So Vs equal to V1 plus V2 plus V3. Irs equal to IR1 plus IR2 plus IR3. Irs equal to I common. We are taking R1 plus R2 plus R3. I get cancelled. Is equal to R1 plus R2 plus R3. If n number of resistors are connected in series combination, if n number of resistors are connected in series combination, Rs equal to Nr. So now we will discuss about resistors are connected in parallel combination. So potential difference is same. V1 equal to V2 equal to V3 equal to V. So across R1, R2, R3. So potential difference is same. So I am taking here. So across R1, R2, R3. Across R1, R2, R3 potential difference is same. That's why Vp equal to potential difference in parallel combination. Vp equal to V1 equal to V2 equal to V3 equal to V. So we know Ohm's law. From Ohm's law V equal to IR. From Ohm's law V equal to IR. I equal to V by I. I equal to V by. From Ohm's law V equal to IR. I equal to V by I. So I am taking Ip equal to I1 plus I2 plus I3. So that's why I am taking here V by Rp equal to V by R1 plus V by R2 plus V by R3. Okay, so V by R1 plus V by R2 plus V by R3 equal to, so 1 V I am taking common, 1 by Rp equal to V I am taking 1 by R1 plus 1 by R2 plus 1 by R3. Okay, so V will get cancelled. V will get cancelled. The remaining values are 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. So if n number of resistors are connected in parallel combination, if n number of resistors are connected in parallel combination, So 1 by rp equal to n by r, rp equal to r by n, r by n. So this is the formula. So you can check here. If n number of resistors are connected in parallel combination, so R1, R2, R3 are connected in parallel combination. Vp equal to V1 equal to V2 equal to V3 equal to V. So Ip equal to I1 plus I2 plus I3, because whatever the current is flowing from the battery, that is through R1, I1, R2, I2. So through R1, I1, through R2, I2, through R3, I3. Okay. So now Ip equal to I1 plus I2 plus I3, V by Rp equal to V by R1 plus V by R2 plus V by R3. VB I am taking common, the remaining value is this one. 1 by Rp equal to N by R, Rp equal to R by N. Okay. So you can try to watch my videos. Okay. So videos in the YouTube channel. So there are many videos are there. So many videos are there. You can get it. Check once those videos. So go and check the videos in the YouTube channel, in the playlist, everything. So you'll get more videos related to physics content. Okay. So now heating effect of electric current, V equal to W by Q, W equal to V into Q. So once again, V equal to W by Q, V equal to W by Q, W equal to VQ, P equal to W by T. So VQ by T, that is P equal to V into Q by T. So we know Q by T is time, Q by T is current, Q by T is current. Okay, Q by T is current. So P equal to Vi. So E equal to P into T. So H, whatever the energy is given to the conductor, that entire will become the form of heat. That is H equal to Vi into T. So V equal to IR. V equal to IR. So H equal to IR into I into T. That is H equal to I square RT. I square RT. Okay, H equal to I square RT. Once again, so V equal to W by Q, W equal to VQ, P equal to W by T, VQ by T, P equal to V into Q by T, Q by T is I, P equal to VI, E equal to P into T. So potential difference equal to VR, H equal to VI into T, H equal to IR into IT, H equal to I square RT. Heat produced in the conductor is okay. So this is about heating effect of electric current, heating effect of electric current, heating effect of electric current. Okay. So next one, short circuit, the direct contact of live wire and neutral wire takes place, then AB amount of current will be drawn from the mains. And overloading is, current is a scalar. Current is a scalar, okay. Overloading means high voltage appliances on at a time, heavy amount of current will be drawn from the mains. Then it may leads to the short circuit. And the next one, earthing. So extra current is there in the electrical appliances that will be sent to the ground. Fuse is a safety device which if more than required limit, if the current is passing inside of the circuit, it melt and break the circuit. So it safeguard the appliances. Okay, next one. So that is about fuse and earthing. And next one, potential of live wire is 220, potential of neutral wire is 0, potential of earth wire is 0, potential of neutral wire, potential difference between neutral wire and earth wire, neutral wire and live wire is 220, potential difference between neutral wire and earth wire is 0, potential difference between live wire and neutral wire is 220, potential difference between neutral wire and earth wire is 0. Okay, so this is about electric current. So if you like this video, please do like, share and subscribe to Student D brand. And if you like this content, you can check my channel. So go and visit my channel. There are many videos are there related to physics. You get it. So I hope you like this video. So please do like, share and subscribe to Student D brand. Thank you so much.